circle of radius r, then displacement and distance of the particle r. Okay, so the question is,
Hello, Upamanyu sir.
yes ma'am,
Sir, this is Kritika.
yes ma'am, yes ma'am,
Sir, I have to pass on information to students. Can you please give me 2 minutes time?
yes ma'am, yes ma'am, you can.
Okay, sir. Listen, students. உங்களுக்கு நாளையிலிருந்து பார்த்தீங்க அப்படின்னா லேர்னட்டி வழியாக தான்ப்பா நீங்கள் வந்து ஜூமிங்குள்ளே வந்து லாகின் பண்ணணும். ஓகே, உங்களுடைய stg.learnity.com போனீங்கன்னா உங்களுடைய யூசர் நேம் பாஸ்வேர்ட் போட்டு அதில் வந்து உங்களுக்கு இது இருக்கும், லிங்க் இருக்கும். நீங்கள் அது வழியாக தான் நாளையிலேருந்து கிளாஸ் அட்டன் பண்ணணும். ஓகே ஓகே ஸ்டூடெண்ட்ஸ். ஓகே சார். சார் யூ கேரி ஆன் சார்.
Okay. So question number 1 is, a particle covers half of the circle of radius r, then the displacement and distance of the particle. Okay, so let us suppose this is a half circle. Okay, the particle started from point A and reaches point B. Okay, I think this type of problem I have done in the class itself. Okay, radius is r, so radius is r. Fine. So what is the displacement of the particle? So when it moves from A to B, displacement is basically the shortest distance between B and A. Okay, so if you think of the displacement between A and B, what is the displacement here? It should be equal to r plus r, that is 2r. Okay, so displacement will be equal to 2r. Very good. Now distance covered. Now distance is basically the total path length which the particle will cover. The particle started from this point and it is moving along this path. Okay, so when it is moving along this path, how much distance it would have covered? The distance it would have covered would be equal to the circumference of the circle. That is equal to how much? That is equal to pi r. Okay, the answer would be equal to pi r. Yes. Okay, so answer number 1, question number 1 answer is 2r and pi r. Okay, question number 2. The hall has a dimension of 10 meter into 10 meter into 10 meter. A fly starting at a corner ends up diagonally opposite corner. Find the magnitude of the displacement. Okay, fine. Yes. 2r equal to d also, no problem in that case. Okay, question number 2 is that a fly started from one of the corners. Okay, so let us draw a cuboid here. Okay, this is the cuboid. Okay, the fly started from, say, the fly started from this corner. Okay, the fly started from this corner A. Okay, and it reaches the opposite corner B. Fine. The length of all the dimensions are 10 meter. Okay, this is also 10 meter, height is also 10 meter, and this is also 10 meter. Okay, so length, breadth and height is 10 meter. So when the fly started from this corner and reaches point B, okay, it reaches point B. So what is the shortest distance? The shortest distance is the line joining B and A. The line joining B and A is the shortest distance between A and B. Okay, it is a cube. Okay, it is a cube. Fine, I did not draw the cube. Assume like a cube. Okay, so displacement is the shortest distance between A and B. Now if you look at this triangle, okay, this is if you assume this point as origin 0 comma 0 comma 0, this point will be what? This point will be, say, 10 comma 10 comma 10, because its x-axis will be 10, y-axis will be 10 and z-axis will be 10. Okay, so in mathematics we can find displacement is equal to what? Square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So 1 is origin and B is the point here. Okay, so we can see that that would be equal to how much? 10 minus 0 whole square 10 square plus 10 square plus 10 square. So answer would come as 10 root 3 meter. Okay. So the answer is 10 root 3 meter. Okay. Fine. Did you understand this or not? The fly moves from A to B. The A and B are opposite corners. Okay. So the displacement of the particle would be the shortest distance. The shortest distance is the line joining the A and B. Okay. You can solve like this also. That you can assume this as a triangle. Okay. This diagonal as a triangle. Okay. So this is the triangle. This is right angle. Okay. This would be 10 root 3, 10 root 2. This would be 10. Okay. So if you join A and C point, this length would be 10 root 2. Okay. This is 10 meter. So it would be again coming as what? 10 root 3 only. Okay. Fine. Another matter is that you draw the diagonal here, A to C diagonal, then B to C. So it becomes a triangle like this. Okay. It becomes a triangle like this. In triangle, this is A, this is C, this is your B point. This would be 10 root 2. This is 10. So AB will be what? Square root of 10 root 2 whole square plus 10 whole square. It will come as 10 root 3 only. Fine. Okay. Both method we can do. Yes, 10 root 3 is the answer here. Fine. Now question number 3. The question number 3 is that a car travels from A to B at a speed of 20 km per hour and returns at a speed of 30 km per hour. What is the average speed for the whole journey? Okay, so the car started from point A and reaches point B. While going, its speed was how much? 20 km per hour. So while going, speed was 20 km per hour, and while coming back its speed is 30 km per hour. Okay, its speed is 30 km per hour. Let us suppose distance between A and B. The distance between A and B is x. Okay, fine. You have to find what? You have to find the average speed. Okay, fine. So distance between A and B is x. So can we find the time taken for a particle from A to B? Means from A to B, how much time it has taken? Say t1. That would be equal to what? That would be equal to speed. That would be equal to how much? Distance by speed. So distance traveled from A to B is x. Speed is 20 km. Now time taken for the particle to travel from B to A. B to A, time is t2. That would be equal to how much? X by 30. So what is the total time taken? Total time taken will be equal to x by 20 plus x by 30. We can take LCM here. This will come as how much? 60. This will be 3x plus 2x means 5x by 60. That will come as how much? X by I think 12. Okay. So total time taken is how much? X by 12. Fine. Now, what is the average speed? Average speed is total distance, that is 2x, because total distance will be how much? X plus x means it started from A, it reaches B, x distance, again from B to A, again x, which means total distance would be equal to 2x. Okay, so 2x by total time taken is x by 12. Okay, total time taken is how much? X by 12. So this will come as 24 km per hour is the average speed. 24 km per hour is the average speed. Yes, you can, in the previous problem, you can use the formula of diagonal of a cube. Then also answer would be 10 root 3. No problem in that. See, again I will explain you. The body started from point A and it reaches point B. So when it is reaching, the body is traveling with the speed of 20 km per hour when it travels from A to B. And when it returns back, it takes the time of 30 km per hour. Okay. So we are assuming that the distance between A and B is x. Okay. So what is the time taken by the particle to reach from A to B? That would be equal to distance by speed. So T1 will be equal to x by 20. Similarly, time taken from B to A would be again same, that is x by 30. So total time taken would be what? X by 20 plus x by 30, which will come as x by 12. So x by 12 is the total time taken for the particle to reach from A to B and then from B to A. Okay. Now we know that average speed is basically what? It is total distance by total time taken. So how much total distance it has traveled? That would be equal to A to B and then from B to A, which is 2x divided by x by 12. The answer will come as x by 24 kilometer per hour. That is the average speed of the particle. Okay. Yes, time is equal to distance by speed. Yes, this formula we are using. Speed equal to distance by time, so time is equal to speed by distance by speed. Okay. How 2x came? See, total distance travel is from A to B is x, A to B is x, then from B to A is x, which means how much distance it has traveled? 2x. Okay. In the same problem, if I would have asked you, what is the average velocity? What will be the average velocity in this case? Average velocity would be 0 in this case. Okay. Why it would be 0? Because the displacement of the particle is 0. Average velocity would have been 0 in this case. Okay. Yes, because x minus means the particle again reaches the same position. So final position minus initial position would be 0. So answer would be 0. Average velocity would be 0. Okay. Now question number 4. A car travels a distance of 2000 meter. In the first half distance, it covers the speed of 40 km per hour. In the second half, with the speed of v. Okay. If the average velocity is 48 km per hour, what is the value of the v? Okay. That is the question number 4th, I think. Question number 4th. Okay. So question number 4th is the uh, the car travels distance of 2000 kilometers. First half of the distance means first half distance means first 1000 kilometers. So it started from point A, it reaches point B. How much distance it has traveled? 1000 kilometers. The distance traveled is how much? 1000 kilometers. Okay. Then first half distance is covered with the speed of 40 kilometer per hour, which means the speed here is how much? 40 kilometer per hour. So 40 kilometer per hour is the speed from A to B. Then from B to C, it has covered a distance of 1000 kilometers, 1000 meters, not kilometers, it is meters, 1000 meters, okay, 1000 meters, and and the speed is how much? V. The speed is V. The average velocity they have given to us. Average velocity is how much? Average velocity is 48 kilometer per hour. So average velocity is is 48 kilometer per hour. Okay, fine. You have to find the v. Again, the same method is there. Okay. First of all, we have to find the time taken from A to B. So time taken from A to B, that would be equal to how much? T1, that is distance by speed. Distance is 1000 meters. We have to convert in kilometers. Okay. So it would be how much? 1 kilometer by 40 kilometer per hour. Okay. Means time taken would be equal to 1 by 40 hours. Okay. From A to B, and same from B to C, say T2 time, that would be equal to what? Again 1 kilometer by speed V. So 1 by V hours. Okay. So time taken from B to C is 1 by V. So total time taken would be how much? Total time taken is 1 by 40 plus 1 by V. Okay. That is total time taken. So total time taken is 1 by V. Okay, fine. Now, what is average velocity? Average velocity is total distance, that is total displacement, that is 2000 kilometers, divided by total time taken, that is 1 by 40 plus 1 by v. Okay, so average velocity they are given as 48. Okay, so I think 48 is the average velocity. So it should be what? 48 equal to 2000 meters. Okay, it should be in kilometers. So put here as 2 kilometers. Okay, 2 kilometers by 1 by 40 plus 1 by v. Okay, so if you take if you cross multiply, we'll get what? 1 by 40 plus 1 by v equal to 2 by 48 means 1 by 24. So 1 by v must be equal to 1 by 40 minus sorry 1 by 24 minus 1 by 40. Okay, so what is the answer we are getting? 1 by 24 minus 1 by 40. That will come as how much? 1 by 60. Okay, so 1 by v is equal to 1 by 60. Therefore, v equal to 60 kilometer per hour is the answer. 60 kilometer per hour is the answer. Okay, so here we have to use by the basic concept that average velocity total displacement by total time taken. Okay, now question number 5. Question number 5. A car runs at a constant speed. Okay, a car runs okay a car runs at a constant speed on a circular track of radius 100 meter, taking it 62.8 seconds for each lap. Each lap, you understand, means lap means after completing one complete circle, one lap. Okay, find the average speed and average velocity on each complete lap. Okay, means if one lap has been completed, then what is the average speed and average velocity? Okay, the question is that we have a circular lap like this. Okay, circular lap. Okay, we have a circular lap of radius 100 meter. Radius is 100 meters. This radius is how much? 100 meters. Fine. Now it takes 62.8 seconds on each lap. Means for each lap it is taking how much seconds? 62.8 seconds. So when it started from point A and again reaches point B, it takes time how much? 62.8 seconds. So what is the average speed? Average speed is total distance. So for one lap, what is the total distance covered by the body? That is 2 pi r. R is how much? 100 by time taken. That is 62.8 seconds. Okay. So 2 pi 100, 2 pi into 100 by 62.8 will come as how much? Approximately 10 meter per second. Okay. So average speed will come as 10 meter per second. Average velocity would be 0, because for one complete lap the displacement is 0 here, so answer would be 0 meter per second. Okay, fine. Yes, so I will show you the slides. Okay, in the last 5 minutes I will show you the slides. Okay, so don't ask me now. Fine, so this was the homework which I have given to you. I hope you all have got the answer correct. Okay, now yes, question answer, this displacement is 0 for each lap, therefore the average velocity would have been 0. Okay, okay, those who have got all the answer correct, then it is very good. Okay, now how 0? No, why 0 minus 0? Average displacement with 0 na, displacement will be 0. When you again come back to the same position, the displacement is 0. If displacement is 0, then velocity will be 0 automatically, because velocity is displacement by time. Fine. Okay. Now next is, now I told you about the average speed. What was the average speed? Average speed was the total distance by total time taken. Okay. Average speed was total distance by total time taken. That I think you know. Like I gave you one example also, that here when you're traveling from one city to another city, say from Trichy to Chennai. Okay, fine. The distance, say suppose it is 400 kilometers. Fine. Time taken is 4 hours. Then what was the average speed? Average speed would have been total distance by total time taken. That is 400 by 44 hours, which will come as 100 kilometer per hour. That is the average speed of the particle. Okay, 100 kilometer per hour. But I told you that average speed will give us the idea of the speed for an interval of time. Okay, it help us to give the idea of the speed for the interval of time. But we cannot say one thing that it gives the idea of the speed. It tells us, see, average speed tells us average speed tells us the speed for an interval of time. Okay, speed for interval of time, that is 4 hours. Okay, so in this case it helps us to tell us the time, it helps us to tell us the speed for a body for an interval of time, but it does not tell us for any instant of the time. Okay, like if I ask you, like example, yeah, I can give you one example, like you started from Trichy at 9 o'clock 9 a.m. and you reach Chennai at 1 p.m. Okay, 1 p.m. Now average velocity will tell us what? It will tell us that the average speed of this whole journey is 100 kilometer, but it will not tell us what was the speed of the particle, or what was the speed of the body when the time was 1 a.m., or what when the time was 12 p.m., 12 a.m. or 11 a.m. We don't know that thing, but we can guess the idea that the average speed of the car or average speed of the body would have been 100 kilometer per hour. For that only, we have another concept that is known as instantaneous speed. That is known as instantaneous speed. Okay, I think when I was teaching you about differentiation, I told you about the instantaneous speed and instantaneous velocity. Okay, instantaneous. Wait. Okay, instantaneous speed and instantaneous velocity. I told you. Okay. Now, what was the instantaneous speed? See, like after traveling 2 hours. Okay, like at 11 a.m. Okay, at 11 a.m. from 11 a.m. to 11 a.m. 1 minute. 1 minute. The body has traveled, say 90 meter. Now, can you tell me what was the average speed in 1 minute from 11 a.m. to 11 a.m. 1 minute? That would have been what? That would have been the total distance, that is 90 meter, by total time taken, that is 1 minute. 1 minute means 60 seconds. It should come as how much? 3 by 2 meter per second. So average speed would have been for 1 minute, it would have been 3 by 2 meter per second. Okay. Now if I start reducing the time interval, like the car has traveled from 11 a.m. to 11 a.m. 1 second. Okay, 11 a.m. 11 a.m. 1 second. Okay, fine. 1 second, it has traveled a distance of say 15 meters. So what was the average speed? The average speed would have been how much? Total distance is 15 meter by total time taken. Total time taken here it will be 1 second. That will come as 15 meter per second. Now I can only say that in 1 second, in 1 second, the speed would have been how much? Means from 11 a.m. to 11 a.m. 1 second, the speed would have been 15 meter per second. Now if I keep on reducing the time interval, okay, if I keep on reducing the time interval, like from 11 a.m. okay, from 11 a.m. to say 11 a.m. 0001 second. Okay, fine. 0001 second. Okay, in that particular time interval, the distance travel was 0.05 meter. Then what would have been average speed? Average speed would have been 0.05 by time taken, that is 0.001 seconds. That will come as 50 meter per second. Okay, so we can see that if i if I keep on reducing, the time interval, the we are getting what? We are getting the speed of the particle or the body for a particular instant of the time, like 11 a.m. Now I can surely say that at 11 a.m. the speed of the car would have been 50 meter per second. Okay, so if I keep on reducing the time interval, I would get what? I will get the instantaneous speed of the particle. Okay, now what is how we are defining instantaneous speed? See, to define average speed, what is average speed? Average speed is total displacement. Average speed is total distance travel. Total distance will be what? Delta x by delta t. Okay, delta is the change in distance. Okay, and delta t is the time taken. Okay, so what is that is the average speed. Now if this time interval is very small, so I can write here as what? If delta t tends to 0, means its value is so small that it is approaching 0, then in that case this average speed becomes instantaneous speed. Instantaneous speed. Okay, then we have to write like this: limit delta t tends to 0, delta x by delta t. Now when a limit delta t tends to 0 or this interval is very small, this delta becomes d, so instantaneous speed becomes dx by dt. So in this way we represent instantaneous speed, that is dx by dt. Okay, so instantaneous speed is basically what? The speed of the particle at any particular instant of the time. Like in this example, the speed of the particle at 11 a.m. was 50 meter per second. Okay, and what does average speed will give us? Average speed will give us the speed of the particle for an interval of time, like 4 hours. In 4 hours, the average speed would have been say 50 kilometer per hour or 100 kilometer per hour. Okay, so that was the interval of the time. But for any instant of the time, like when you see the clock at 11 a.m., like you can the very best example is that instantaneous speed is your speedometer. Okay, so when you see your speedometer in the bike or car, you will see that the speed will change. Like when you are traveling fast, it becomes 80 kilometer per hour, 81, 82, 83. That 81, 82, 83 is giving us what? It is giving us the instantaneous speed of the particle. So when you look at your clock, okay, if you look at your clock at 11 a.m., your car was traveling with the speed of 50 kilometer per hour. That is basically what? That is the instantaneous speed of the particle. Okay, so the speedometer gives us the instantaneous speed of the particle. Okay, fine. Did you understand what is instantaneous speed? Yes. If the time interval is very small, then this average speed becomes instantaneous speed. Okay, so that instantaneous speed means the speed of the particle at any instant of the time. Any instant means like 11 a.m. 11 a.m. 1 second, 11 a.m. 2 second. Okay, that is the instant of the time. Okay, fine. I hope you understand what is average speed. Okay, average speed is represented by dx by dt. The average speed is represented by dx by dt. Okay, Now average velocity. Oh, okay, I'll tell you about average velocity. It is the difference between. Yes, yes. If the time interval is very, very small, then speed becomes instantaneous speed. Okay. Now, what was the average velocity? I explained you what it was the average velocity. Average velocity is average velocity is total displacement, total displacement by total time taken. Total time taken. Okay, that was the average speed. Now we can assume one condition that at time t equal to t1 second, let at time t1 second, the particle particle was at x1 meter. Okay, at time t equal to t2 second, particle was at x2 meters. Then what was the average velocity in that case? Average velocity would be displacement of the particle. It is x2 minus x1 because at time t1 it was x1. At time t2 it becomes x2. So what is the displacement? That is x2 minus x1 by t2 minus t1 is the average velocity here. Okay, or we can write this as what? Delta x by delta t. Now whenever we are writing displacement, we have to put this arrow. This represent the vector form of the displacement. Okay, so arrow represent the vector form. So whenever we are writing displacement, we are writing the arrow there. Okay, I will explain you what this arrow mean in vectors and scalar and vector quantity. Okay, for now you understand, whenever there is vector, we have to put an arrow on the object. Okay, fine. Okay, now we can represent average velocity in terms of graph also. Like if you look at this graph, okay, if you look at this graph, if I plot x on the y-axis, means displacement on the y-axis and time on the x-axis. Okay, now if you take this condition, at time t equal to t1 second, the particle was at x1 position. Okay, at time t equal to t2 second, okay, at time t equal to t2 second, the particle was at which point? X2 meter. Okay, x2 meter. Fine. Now, what is displacement? Like see, we can represent the graph point as p1 point. This is p2 point. Means these are the point on the graph. Now, what is displacement? Displacement is the shortest distance between the initial position and final position. Which means if I join these 2 points, p1 and p2, this will be the displacement between the particle. Okay, so the line joining these 2 points p1 and p2 is the displacement of the particle. Now can you find the average velocity? Average velocity is what? X2 vector minus x1 vector by t2 minus t1. Okay, that is the average velocity of this particle. Now what is x2 minus x1? X2 minus x1 is the distance between P1 and P2, which is the shortest distance. Means if I join the line from P1 and P2, I will get the displacement of the particle. Okay, I will get a displacement of the particle. Fine. So that is how we represent average velocity. So velocity average will be equal to delta x vector by delta t. Correct now? Now, now, if you remember this differentiation, I told you what is the line joining P1 and P2 is the secant of the graph. Okay, if you remember that line joining P1 and P2 is the secant of the graph. Okay, now if I find the slope of this secant, the slope of the secant is theta angle. Okay, so this was the slope. So you can see that if I draw a triangle like this, triangle P1, P2 and O, this will be angle theta. Correct now? This is your angle theta. Now, can I say that tan theta will be equal to x2 vector minus x1 vector by t2 minus t1, or we can say this as delta x vector by delta t vector. Therefore, can I also write here as tan theta would be equal to what? B average. And what is tan theta? Theta is the slope of P1 P2 line. Okay, or we can say the slope of the secant which is joining P1 and P2. So tan theta is the slope of secant joining P1 and P2 point. Okay, that is how we can represent average velocity in the form of graph. Okay, fine. Now again, the concept remains same. That differentiation concept and integration concept remains same. Then I told you this is the secant. Now if I reduce the time interval, okay, if I keep on reducing the time interval, fine. See, if I reduce the time interval, then P2 will come closer to P1 point. Okay, so if I keep on reducing the time interval, the P1 will come closer to P2 point. Okay, and if and if and if P1 if this time interval is very small, if the time interval is very small, then P1 and P2 will be almost coinciding. Okay, see, so initially we have this point that initially at T1, okay, the particle was at x1, okay, at T2, okay, particle was at x2. Okay, now if I reduce the time interval, means if T2 becomes here, means time interval has reduced. If T2 is here, then time interval is reduced. And if I take T2 very small, means at this point, what will happen? This yes, yes. So what will happen, that if the time interval is very small, okay, then P1 and P2 point will be almost coinciding with each other. Okay, so if the time interval is very small, see, if time interval is very small, say this is T1, this is your T2 interval. Okay, now this P1 point and P2 point will be almost coinciding. Now if I draw the graph, if I draw the straight line in this case, then this straight line will be what? The tangent to the graph. The straight line will be tangent to the curve. Okay, now the slope of the tangent, yes, the secant become tangent to the curve. Now in that case, if I find the average velocity, then average velocity would have been what? Delta x vector by delta t. Now you can see the time interval is very small. So you can say that delta t approaches to 0. When it approaches to 0, then this average become instantaneous. Instantaneous velocity. Okay, it becomes what? Dx by dt. Now, 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 if I draw the tangent here, if I draw the tangent here, the tangent would be what? The slope of the tangent, the slope of tangent will be equal to what? The instantaneous velocity. Now, instantaneous velocity is represented by v only, v. So whenever we have to represent instantaneous velocity, we simply write v. Whenever we have to represent average velocity, we will write v average like this. Okay. So the slope of the tangent would be the instantaneous velocity at a point A, or we can say at a time interval t. Because since t1 and t2 is very close to each other, we can assume that time interval in time to be t. So the slope of the tangent would be instantaneous velocity at time t. Okay, that is what we can represent. We can represent the instantaneous velocity on the graph. So you have to remember that instantaneous velocity of a graph is the slope of the tangent to the graph at that time interval. Okay, at that time, at that instant of the time. Okay, fine. So you can write a note here. Wait, you can write a note here that if P1 and P2 are very close, then the slope of the tangent, the slope of tangent to the curve, the slope of tangent to the curve will will become instantaneous velocity at that instant of the time, instant of the time. Okay, fine. That is known as instantaneous velocity. Fine. P is that point, means velocity at that point. Okay, if P1 and P2 are very close to each other, then the slope of the tangent will be the instantaneous velocity at that instant of the time. And instantaneous velocity represented by V, simply V. Okay, so instantaneous velocity represented by V equal to dx by dt. That is how we represent instantaneous velocity. That is V dx by dt. Okay, now somebody asked me that what was the difference between instantaneous velocity and instantaneous speed. Instantaneous velocity is the vector quantity, and instantaneous speed is the scalar quantity. So speed is scalar and vector velocity is vector. Okay, so that is the difference between instantaneous velocity and instantaneous speed. Okay, fine. No. See, they are not same because instantaneous velocity is by d dx. Here x is the displacement. So here x vector is the displacement. Correct now. Both are different thing. Don't confuse with speed and velocity. A unit would be same. Unit would be same, but x here is displacement, not distance. So average instantaneous velocity is dx vector by dt. X is the vector quantity there. Okay, and average speed is dx by dt, where x is the scalar quantity. Fine. X is the distance here. X is the displacement here. Okay. Fine. I hope you understand this. I have already explained you in differentiation only, and I was explaining you differentiation. Okay. Fine. So that is what average instantaneous velocity means. Okay. Okay. So you can see the slide. So we started from this slide number 1. Okay. Yes, instantaneous velocity is a vector quantity. Yes, velocity can be negative, but speed cannot be negative. Velocity has direction also. Okay. So direction can be negative. Magnitude is positive only. Okay. Any other doubts you are having? Speed speed can be zero if you don't move. If you don't move, if you are at rest, means speed is zero. Physics portion, I think it should be. I, I think it would be kinematics 1D only up to motion under gravity. Okay. I will tell you tomorrow. Okay. Today I think doubt clarification class is there for you all. Homework tomorrow I'll give. Okay. How velocity can be zero if displacement is zero. Okay. Like average velocity when you move in a circular path, again you come to the same position, then the average velocity would be zero now because displacement is zero in that case. Okay. Okay. Thank you all.